How we doing? Good? Yes. Say it again? Oh, yeah. How was everybody's weekend? Good? Oh, always, right? What questions do you have? All right, so we got a test on Wednesday. Posted a couple of reviews on Moodle yesterday. I'll get a practice exam posted this afternoon as well. So you have those. Basically, your exam is over what we've covered in Chapter 9. So solving systems and equations, being able to use matrices to solve equations, doing Gaussian elimination, doing matrix operations, finding inverses, and then solving our non-linear systems like we've talked about. Party boys, like we started talking about on Friday, and we'll finish up today. So last time when we were talking about solving non-linear systems, we talked about solving and using substitution, solving for one of the variables, putting that in for the other variable, figuring out the values for the one variable, and then going back and figuring out the corresponding values for the first variable that we talked about. But we also noticed that it might be beneficial to us to be able to use elimination like what we did before with solving systems of equations. So let's look at this system here where we've got y equal to x squared plus 8x, and we've got y equal to 2x plus 16. We could solve this with substitution without too much difficulty if we wanted to, since we have y is equal to the same thing for two different equations. But notice it's also just as easy here, relatively speaking, to eliminate the y's. What can we do to these equations to eliminate the y's? You multiply 1 by a negative and add, right? Okay. So I can take, say, that second equation. Let's multiply it by -1. Multiply everything by -1. And then if we add, the y's go away. We get x squared. 8x minus 2x will give us a plus 6x. Oops. And then we'll have a minus 16. That's a 0 over here. So the y has gone away. So now we want to be able to solve this quadratic that we're left with. What should we do on the right-hand side there? Factor it? How does it factor in this case? X plus 8 and x minus 2. That'll work. So what are your two solutions for the x then? -8 and +2. Good. What do we do with each of those then? Plug them into one of the equations, right? Doesn't matter which one. You should, as a matter of fact, it's a good check that if you plug them into either of them, you should get the same answer, right? Because again, if we think about these as graphs, it's where these graphs should be intersecting each other. So if we put in x equal to -8, we get y equals -8 squared plus 8 times -8. -8 squared gives you 64, and then you get a minus 64, so we should get 0 for that one. Put in your 2. You get 2 squared plus 8 times 2. 2 squared is 4. 8 times 2 is 16, so you should get 20. So what are the two solutions here in this case? Good. Now let's think about this for a second. Does it make sense that we get two solutions for this one? Let's look at this first equation. You've got y equals x squared plus 8x. What kind of shape are you going to get for that? A parabola, right? Which way does it open, up or down? Up, right? Because you got a positive on the x squared, so it's going to go this way. The other one's a what? A line. Positive. So it's going to go this way. So you're going to get a parabola and a line. Two cross two places. Okay. Okay. Well, let's see about doing another one here. This one again asks us to solve by elimination. We've got x to the fourth plus y cubed equals 17. And we've got 3x to the fourth plus 5y cubed equals 53. We'll need to multiply one of the equations by something in order to eliminate. In order to eliminate. Which variable do you want to eliminate, the x or the y? You want to eliminate the x? Okay. Literally doesn't matter which one you choose, just pick one. What do we need to do? If we want to eliminate the x, what do we do first? Good, yeah, good move. Multiply that first equation by -3. Don't forget to do that to everything, like I just tried to do. I almost forgot to multiply it on the right-hand side. Make sure you multiply both sides by -3. When we add the two equations together now, what do we get? Good, exactly right. So of course, we multiply by -3 for the first equation to get rid of the x's. We add the y's together, we should get a 2y cubed. Add the right-hand side together, we also get a 2. Divide both sides by 2. Get y cubed equals 1. Now what do? Cube root. Do I need to worry about plus or minus if I do a cube root? We do have to, if we do the square root, we always have to worry about plus or minus. Do we have to do that for a cube root? No, good. For real numbers, there's only one cube root that you'll get, but when we have a square root, we'll always get plus or minus. So we get y equals 1. Pardon me. What do we do now? Okay, plug it back into, again, either of the two equations, right? Which one would you rather plug it into, the first or the second, do you think? First one, right? It's got fewer coefficients to worry about, right? Plug it back into the first equation. We get x to the fourth plus 1 cubed equals 17. 1 cubed is 1. Subtract it over, we'll get x to the fourth equals 16. What do we need to do to both sides now? Fourth root. Now, like I asked you in the previous, if we do the fourth root of both sides, do I need to worry about plus or minus? Yes, I think we do. Okay, good. Yeah, so remember, when you do an even power, it doesn't matter if it's positive or negative. When you do an even power, it becomes positive, right? So what I'm saying is that negative 2 to the 4th is the same thing as 2 to the 4th. So we'll get two solutions here. You'll get x is equal to plus or minus 2. For odd powers, that doesn't work, and that's not the same thing, right? Because if we do odd powers, an odd power of a positive is a positive, but an odd power of a negative is a negative. So when I do a cube root or a fifth root or a seventh root, I don't have to worry about plus or minus, because it's only because of the fact that if you do an odd power of a positive, it's a positive, but if you do an odd power of a negative, you get a negative. I do have to worry about it for even roots, though. All right, so finally, then, what are the two solutions? Good, 2, 1, and negative 2, 1. Process okay on that? We can do the same type of problem here, even if we don't have, notice that all the non-linear equations we've had so far have been powers of x's or powers of y. We can be a little bit fancy and have them be other functions of x or y and still not be a linear system, and still want to try to do the exact same ideas here for solving, either do a substitution or an elimination. Notice in this next example, we've got log of x and log of y in each of the equations. That's what makes it not linear, right? Because again, x and y cannot appear inside of another function, right? The x and the y can't be an input of another function. So that's what makes this not linear. But we can still approach it the same way. This one's asking us to solve it by elimination. So again, either eliminate the x or eliminate the y. Which one's easier to eliminate the way this is set up? The y, right? What do we do to the equations to eliminate the y? Just add them together, right? If we add these two equations together, what do we get when we add them? Good. 3 log x equals 3 over 2. Divide both sides by 3. We'll get log x equals a half. Dividing by 3 is the same thing as multiplying by 1/3, so your 3 can cancel. So we'll just have 1/2 on the right-hand side. And this one's a good little review for final exam types of things. When you write log and there's no base, what do we assume the base is? Log 10, right? So this is log base 10 of x equals 1/2. How do we rewrite this equation so that we can solve for x? So the base is 10, right? What's the exponent? We want to write this in equivalent exponential form to solve it. What's the exponent? It's 1/2, right? Remember, the answer to a logarithm is an exponent, right? 10 to the 1/2 equals x. So we have what the x value is here. And then just to remind, if we have a fraction exponent, what's another way to rewrite the 1/2 power? Square root. Good. Yeah. So this says x is square root of 10. Now we need to plug this in and figure out what log of y is. I would probably plug it into the second equation just so I don't have to deal with the 3/2 there. That's just me. So if I go over here, pardon me, into this one, if x is equal to square root of 10, you'll get, I'll write it as 2 log of 10 to the 1/2
minus log of y equals 0.
Remember, log without a base is base 10. And remember, when you're trying to simplify logarithms, the question you want to ask yourself is, what power do I need on the base to give me what the input is, right? I mean, remember, logarithms are exponents. The answer is an exponent. It's what exponent do you need on the base to give you the inside. So let me ask you this way. What power do you need on 10 to give you 10 to the 1/2 power? Ten to what power gives you 10 to the 1/2 power? Don't overthink it. 10 to what power gives you 10 to the 1/2 power?
Ten to what power gives you 10 to the 1/2 power? 1/2, right?
What power do I need on 10 to give me 10 to the 1/2? Well, I need to use a half, right?
Like I said, don't overthink it. When I have it written this way, when the base is the same here and here, because right, this is base 10 here. When the base is the same here and here, the answer is just the exponent. Okay? So you get 2 times 1/2 minus log base or log of y equals 0. 2 times 1/2 is 1, so you get log y has to equal 1. And now I have a similar equation to solve like we had in the previous one. How can you rewrite the right-hand side? Or how can you rewrite that equation in exponential form? Get 10 to the 1 equals y, right? So your y is 10. So what is your solution in this case then? Yeah, square root of 10, comma 10. Good. So again, remember there's a couple of ways to think about it, but in general, when I do log base b of b to the r power, I just get the power, the r. This is, remember that exponential functions and logarithmic functions are inverses of each other. They undo each other. So this went into the exponential function. You took the output and plugged it into the logarithmic function. It undoes what the exponential function did. So it gets you back to where you started. They're inverses of each other. That's all we have up here with very specific numbers for these things. Not that it's as important for this particular exam, but for the final, making sure you remember your log properties is going to be important. What questions do you have on that one? Is the process okay minus the remembering how to handle logarithms? The process isn't any different than what we've been doing, is it? All right, let's see if we can apply this stuff that we've been doing to a couple of word problems. They tell you that a perimeter of a rectangle is 70, and the length of the diagonal, or one of its diagonals, is 25, and it wants to figure out the length and the width. So just to help out here, let's draw a picture of a rectangle. Doesn't really matter what the letters are. But since it says find length and width, I'll label one of them L and one of them W. You can label them X and Y if you want. You can use pictures of emojis if you want. Doesn't matter what the variables are, as long as you have two different symbols to represent the two different quantities. In general, if you want to find values for a certain number of variables, you need the same number of equations. If you want to find solutions that are not infinitely many solutions, you typically need as many equations as you have variables. So in this case, since we have two variables, we probably need two equations. So hopefully there's enough information given to us in this problem that we can get two variables, or excuse me, two equations out of it. So the first sentence, or the first part of the sentence says that the perimeter is 70. Can you give me an equation involving the length and the width from that statement that the perimeter is 70? What is perimeter again? Good. Yeah, it's the distance all the way around the outside, right? So I have to do length plus width plus length plus width going around, right? So what would the equation be then? Good. That's one equation. Good. The other part tells you that the diagonal is 25. We have a rectangle, so I know that this has to be a right angle here. So what equation might help us, or what famous theorem, even better, might help us get an equation that relates L and W using the diagonal? Yeah, Pythagorean theorem I think will help us out. Yeah, what's the Pythagorean theorem tell us? Yeah, the a squared plus the b squared equals c squared. A and b are the legs of your right triangle, and the c is the hypotenuse. So using Pythagorean theorem, what other equation will we have involving L and W be? $25 squared, right? Yeah, I got to square it. Good. So now we have a system of two equations and two variables. So now I've got a system to solve, hopefully. We're going to figure these values out. All right, so our two main methods for solving systems of equations, especially nonlinear systems of equations, are either substitution or elimination. Notice in this case, I can't easily eliminate. I'd have to try to multiply by a variable, which is always a bad idea. So let's use substitution instead. Let's use the first equation and solve for one of the variables. Doesn't matter which. I'll just use the first equation to solve for L. So subtract the 2w over and divide by 2. Make sure you divide everything by 2. So you get 35 minus w for the expression for L. What do we do with that now? Yeah, substitute it into the second one, right? So take 35 minus w squared plus w squared equals 25 squared is 625. Go ahead and just simplify that now while I'm at it. Probably need to multiply this thing out and then refactor it. if we multiply this thing out, we would get W squared for that part. I'll get a minus 70W when I do the 35 times W, or 35 times negative W, and you have to do it twice. Oh, goodness. What is 35 squared? Thank you. That's what you said was 1225? Yeah, good. All right. So now again, since we have a quadratic equation, we need to make sure we set this equal to 0. So if we subtract the 625 over, we should get 600. So you get W squared minus 70W plus 600 equals 0. I think the two most obvious numbers that multiply together to give you 600 are 60 and 10. At least looking at that, it seems like those would be the two most obvious things to multiply together to give you 600, and that happens to give you the minus 70 in the middle, doesn't it? That's kind of nice. So this tells me that W is 60 or W is 10. You okay so far with that? I know it's a little bit bigger, but not too bad. Again, do not spend 20 minutes trying to see how something factors. If you don't see how it factors right away, use quadratic formula. Quadratic formula always works, no matter what. If you see how something factors, that's typically the quicker way to do it. But if you don't see how it factors, then don't sit there all day and try to figure out how it factors. Just use quadratic formula and go through it. Now what do we do with these two numbers? Yeah, plug them into the L equation, right? So if W is 60, then the L is going to be 35 minus 60, or negative 25. Now let's think about the problem. What kind of a shape are we dealing with? A rectangle. Does it make sense for the length of a rectangle to be negative? No. Okay. So this one doesn't make any sense. We might as well just throw it out, right? So this one doesn't make sense in the context of the problem. So throw that one out. So now do the other one. W equals 10. You get 25. So our length is 25, and the width is 10. Anyway, it doesn't make any sense. That doesn't make any sense for the length of the, it can't be the length of the rectangle and the length of the diagonal. Somewhere something went haywire. I can't have the length of the side of that rectangle be the same as the length of the diagonal. The hypotenuse has to be longer. So what went wrong? $35 minus 10 is certainly 25. That's multiplied. 1225 is definitely right for that. Subtract the 625 over, definitely get 600. 60 times 10 is 600, and 60 and 10 work. 25 squared is 625. 70 divided by 2 is 35. There's nothing wrong there. Okay, there is something not right. Something is not right somewhere. It may just be with the setup of the problem, but something is incorrect here because there's no way that this can be 25 and that can be 25. They can't be the same. So something is not right somewhere in there, and I'm not going to spend the next 10 minutes trying to figure out what's wrong. But the process, okay. Setting up the two equations and doing the process a little bit. Yes. We didn't. We went from here to here. So subtracted the 2w over here, and then divided everything by 2. Yeah. So this was still 25 squared here. That came down here after we substituted in the 35 minus the other. So when you do 35 minus w squared, I've got to multiply it by itself. So here's where the w squared came from multiplying those two pieces together. And then your 70 will come from that one and those getting multiplied together. Yep, you're welcome. Right. Any other questions on the process on that one? That okay? Any questions, Al? Oh, thank you. That's where it is. Jeez. There it is. Thank you. I knew there was a problem. Here it is, right here. I forgot to add the w squared on there. The w squared minus 70w plus 1225 is multiplying out that piece right there. I forgot to add the w squared on. Thank you. That would have bugged me until I looked at it later. So this should be, there still should be a plus w squared here on the end. That should be on here, which changes that to a 2. Well, that was unfortunate that it actually factored nicely, because I figured the numbers were worked out nicely in there for that. So let's erase all of this. My apologies in that. Okay, all right. So now that we have the 2 in there, let's divide both sides by 2 just to help us see how this is going to factor, hopefully. Let's see. So we should get w squared minus 35w plus 300 in this case equals 0. Unfortunately, the 30 and the 10 doesn't work very easily. 5 and 60 doesn't work very easily. I don't think this one's going to factor as nicely. Not that I'm seeing it. Let's see. Use my calculator rather than me trying to figure it out. 1540. Say it again. 1540. Oh, 50. Oh, thank you. That works. Forgot that one. Thank you. That's much better. So our W should be 15 or 20. That makes me happier because that actually makes more sense to me that this worked out this way. So again, plug these in. Oops. If your W is 15, you get 20 for the length. If your W is 20, you get 15 for the length. Oh, it makes me feel so much better. This makes sense to me. I apologize for that. Got the W squared in there. Anyway, notice that the width being 15 and the length being 20, or the width being 20 and the length being 15 are essentially the same triangle, aren't they? You put the triangle and put it on the side, essentially. So really what you're looking for is a triangle where you've got a 15 by 20 rectangle, or I'm sorry, one rectangle, not triangle. So you should have a 15 by 20 rectangle will work. All right, besides my flub up with not forgetting the adding the w squared in there, again, the process okay. This is also why it's important, with me messing up, I wish I would have done it on purpose. Me messing up makes it show you that making sure the answers make sense in context is important, right? I know something was wrong because that length could not be 25. It was impossible for that length to be 25. So I knew somewhere along the way something was wrong, so I needed to go back and correct it. Any questions on doing these solving things? Is this okay? Well, let me go ahead and, like I said, I already put 2 reviews on Moodle. Let me go ahead and hand out one of these for you here so you have a printed copy of it. And we'll chat about it just briefly before we go. So notice that this goes through pretty much what we've talked about as we've gone along here. So we've got first just solving through substitution method. That was the first thing that we talked about. Just going through systems of equations and solving with pardon me, either a substitution or elimination. And we've gone back to those methods here where we've done non-linear systems. The third one is going to give you some practice on making sure you can write things with infinitely many solutions. Fourth one there is just solving a system. Fifth one talking about can you identify specific things in a matrix, specific entries, what the size is. Order and dimensions mean the same thing, by the way. Order of the matrix is the same thing as dimensions. 6 is just making sure you remember that if you're going to write an augmented matrix, you put it in kind of a standard form. Right? Make sure all your variables are on one side, constants are on the other, so you can figure out the coefficients. The next few are just, can you perform the operations? So that's important for being able to do Gaussian elimination, Gauss-Jordan elimination, which is what the next couple deal with, which we talked about in section 3, I believe it was. All right, I'm going to put it in a matrix and write your augmented matrix and go through the process of getting a 1 and then get zeros below and so on down the line. We've done it several times. We do that again for doing inverses, which is what 13 is about. That was in section 5. 14 is just being able to do the operations, making sure you know how to do matrix operations of adding, subtracting, and doing scalar multiplication and matrix multiplication. 15 and 16 go back to the idea of being able to write a system as a matrix equation and then use an inverse to solve the system. 17 and 18 are just playing around with making sure you understand what it means for matrices to be equal and set up a system of equations to be able to solve that. And then the last two are what we just talked about with doing the non-linear system.
So again, this is indicative of the type of problems that I'll ask on the exam. Okay. There's another review just like this on Google currently, and I will get a practice exam also posted this afternoon. We have that too. Any questions about anything else? Like I said, it shouldn't be a surprise if there's not any. Well, if you got questions later, holler at me. I think Logan sent out an email too, didn't you, yesterday about review times? Yeah, so check your email for that. If you're looking for the SI reviews, come see me. I'm here most of the day tomorrow. I've got class at 11, but most of the rest of the day I'll be around too if you've got questions. So, exam Wednesday, and then we'll talk about final exam Friday. Your final exam is scheduled for a week from Wednesday at 8 a.m. in here. So a week from Wednesday at 8 a.m. in here for your final. I'll remind you that on Friday as well. All right. Have a good one. We will see you on Wednesday, if not before.